right, so we are looking at linear equations. So yesterday and the day before we talked about function notation. We learned how to evaluate expressions in function notation. So as our warm up and to get us thinking mathematically, we're going to evaluate each of the following four functions for those given points. So if you were to find f of 0, it means you are plugging 0 in for x. So 2/3 x plus 7 gets a 0 where there's an x. So it becomes 2/3 times 0 plus 7. Anything times 0 is 0, so f of 0 is equal to 7. For f of 1, where you have x, you replace it with a 1. So we get 2/3 times 1 plus 7. So that is like 7 and 2/3. If you wrote the mixed number as an improper, that is 23/3. In example 2, you're plugging -2 in for x. So you get 3/5 times -2 minus 2. So that's like -6/5 minus 10/5, which is -16/5. And for 4, 3/5 times 4 minus 2 is 12/5 minus 10/5, which is 2/5. And then number 3, you have f of -2. So you plug -2 in for x. So you get -6 plus 1, or -5. And f of 1 is 3 times 1 plus 1, which is 4. And then in number 4, same idea. You have 1/2 times 4 minus 8. Half of 4 is 2. 2 minus 8 is -6. And then in the next example, you have 1/2 times 0 minus 8. So anything times 0 is 0. So you get -8. Yes. Go ahead, real quick, because I can give you the definitions later at the end. Either or. All right, so that leads us into our vocab, which maybe it'll clear up. Oh, there we go. So some of the definitions I did for you, some of them you're going to have to copy down. So what we want to do is take the idea of the concepts we just talked about and discussed and determine whether functions are linear or not. So a function is linear if the only operations on the function are addition, subtraction, and the only multiplication is between a number and a variable. A variable is not raised to a power. So in example A, we have 8 minus 3/4 x. This is linear because the only multiplication is between a coefficient and a single x variable. In example B, that is not linear. It is what we call a rational function. And it is not linear because we have division by x. So the directions are state whether it is linear or not, and then tell me why or why not. So for A, it's because it only has addition, multiplication. For B, it is not because you have division by x. And in example C, it is also not linear. And that is because you have x being multiplied with y. So you cannot have two variables multiplied together, or else it is nonlinear. If you have two variables times each other, it is nonlinear. We talked about standard form. So in our definition of standard form, it has to have a positive a value and no fractions. So in that first example, we have 6x minus our 3x minus 6y minus 9. So to get that into standard form, we have to move over the 9. So we're going to add 9 to both sides. The next time you ask me to use the restroom, the answer will be no, because you're not permitted to go to the cafeteria and buy food. It's not available during lunch. Good try. The vending machines don't work at lunch. They turn on at 2:20. Yeah. I've worked here a long time. So vending machines don't work during the day. Your A value is 3, your B value is 6, and your C value is 9. Solve for ax plus by equals c by moving over your 2y to be with your x and your 5 by itself. So we have negative 5 equals 4x minus 2y. And then this, in order to be in standard form, has to have the x and y's on the left and the numbers on the right. Yep. So the only problem with that is then you have to divide everything by -1 because by the definition of standard form, the a value cannot be negative. And then in the last example, what we need to do is multiply everything by -10. So you have 3x equals -80y plus 150. And then we're going to add our 80y to the other side. And I identify my A, B, and C.